Um, Now welcome to this oscillator section video. Okay, so first let us explore the syllabus content here. Okay, so if you consider the syllabus, it will start with what is the meaning of oscillator, what is the meaning of positive feedback, conditions for oscillations. Then we have some networks, that is ladder network, Wien bridge oscillator, then multi-vibrator, then single stage a stable oscillator, and crystal controlled oscillator. So already I have completed this positive feedback topic while discussing the negative feedback. Okay, so first let us understand what is the meaning of this oscillator. Okay, so as you can see over here, an oscillator is a circuit which produces a continuous, repeated, alternating waveforms without any input. So without any input is very important point here. So these kind of circuits require a main thing is positive feedback is one condition, and there is one criteria, means one condition. That condition is called as or named as Birkinson criteria, which is usually a unity feedback factor gain. Okay, it is a kind of gain. Already we know the meaning of gain is output parameter by input parameter. So if you are considering with respect to voltage, you have to consider here output voltage divided by input voltage. Okay, now if you consider conditions for oscillations, so if I consider this box as a one oscillator, it will be able to produce, as I told you earlier, continuous waveform. Okay, so without any input, means externally we don't give any input. Okay, circuit itself, after reaching those two conditions, it will be able to produce such waveforms. Okay, so if you want to have a continuous beep sound, alternating beep sound, we can use the oscillators. So condition for oscillator is what? Unity feedback and input is 0. So let us understand these 2 points carefully here. Okay, if I consider the voltage gain, okay, of the positive feedback, so what is that? V out by V in, or total gain of the positive feedback is what? A divided by 1 minus A beta. Okay, in which we expect that A beta is, it should be 1. If A beta is 1, then what will happen to this entire equation? This entire equation will reduce to A by 0. That will lead to infinity, means this entire part A divided by 1 minus A beta will be infinity. That means V out by Vn will be equal to infinity, which implies the gain is infinity. As we can prove with respect to mathematically here, input will be 0. So how we have to prove? If you interchange infinity and Vn position, anything divided by infinity, it will lead to what? 0. So that means Vn is 0. Okay, now going to the one of the first topic, which is ladder network oscillator. So what is a ladder network oscillator? Okay, so it is a circuit which is capable of producing a continuous sine wave. So it should be able to produce continuous sine wave signal, something like this, a continuous sine wave, when the criteria are satisfied. Okay, at the desired frequency. But it uses what? Positive feedback network having the amplifier circuit. So keep in mind that if you consider an oscillator circuit, it will be having two parts within that. One is the amplifier circuit, okay, and another one is the feedback network. So this feedback network is connected to amplifier through output of the amplifier is connected to feedback. So it is a continuous process. When A beta becomes 1, that indicates the Birkinson criteria. So in that case, it will be able to produce the required oscillations. Okay, So in particular, if you consider ladder network or RC coupled oscillator, there is another name also, that is RC oscillator. So what it uses is, it uses a common emitter, that is C means common emitter amplifier circuit. Okay, then a feedback network which will be having a three-stage RC network. So the concept is very simple. The common emitter amplifier circuit, it will produce, if you give say for example input something like this, okay, it will produce a 180-degree phase shifted output. So what we want is, we want in phase, that is this output and this input, they should be of the same phase. It should be like a sine wave only, not like 180-degree phase shifted. So what we need to do is, we need to put some circuit before this, okay, so that it can produce another 180-degree phase shift, so that you can obtain this condition. So this is obtained by using these three-stage RC network, where one RC network can give you 60-degree phase shift. So 60 into 3 means what? 180-degree. Okay. So here, just to understand the circuit and how it is used, that's all I have to explain. Okay. So if you consider this particular circuit, as you can see, there is a transistor which I am writing it here as a Q. Okay. So this transistor is connected in common emitter, as emitter is common to left side and right side. Okay. So this, the things which are shown in red, they are nothing but the amplifier circuit contents, and things which are shown under blue, they are nothing but the feedback network. So this one stage, second stage and third stage, these things will produce another 180-degree phase shift. So 180 here and 180 is already, this is producing. So 180 plus 180. So it is already producing a reverse 180. So it will give you 180-degree phase shifted only. So output will be what? Output will be again in phase. Okay. So here if you give something like this, if the output is something like this, what will happen here? It will be out of phase by 180. So anyhow this will be producing 180 out of phase only, 180. So input is this. So what will be the output? Output will be in phase, that is 180. Okay, getting this? Okay. So to compensate that 180-degree phase shift, we use this three-stage RC network. That's all you have to explain. So the same diagram can be shown in a simplified way like this only. So what I explained, that is written over here. So just go through this. Okay. And usually the frequency at which such circuit resonates, so that frequency equation is given by 1 by 2 pi RC into root 2n, where n indicates the number of RC stages. So if there are 3 RC stages, means 2 into 3, that will be root 6. Okay. So this thing you have to write it in the examination, this equation, and the main significance of amplifier block and what? The oscillator block, feedback network will help to produce 180-degree phase shift value, so which will be again shifted by 180-degree in the amplifier. So we obtain what? The required phase shift. Okay. So one example is given. So if C and R value are given for a 3-stage, so just put the value of R and C and you will get the frequency value. Some practice problems I have mentioned, so just go through these things. Okay. Similarly, on the same basis, you have to consider the Wien bridge oscillator. So Wien bridge oscillator, it is the another method used to produce a sine wave signal only, again like a RC phase shift oscillator. Okay. So but here what we use is, we use a op-amp as an amplifier block. Okay. So op-amp will be acting like an amplifier block, and this Wayne bridge oscillator, which will be consisting of something like RC combination, R1 C1 and R2 C2, which will be connected in this way. Okay, as you can see, A and B, especially this you concentrate here, A and B ends are used as input, C and D are used as output. This is the feedback part, where input is what? Input to the feedback is what? AB end. That means op amp output will be connected here. Its output from CD will be connected back to op amp. Okay. So as you can see, R1 and C1 are getting the output from op amp. R1 and C1, that is at this point AB, and from CD it is being connected to feedback, so it is a positive feedback. Okay, so this is the required thing, okay, in the Wayne bridge oscillator. Okay, so here if you refer to this, just have to explain what is the significance of this op amp and this feedback network, and condition for oscillation from this circuit, it is already derived. Just you have to write it here. If all the values of R1 R2 are R, C1 C2 are C, so then voltage gain of such network can be given as 1 plus C1 by C2 R2 by R1, which will be equal to 2, sorry, R3. And desired frequency equation is nothing but 1 by 2 pi root of C1 C2 R1 R2. If C value and R value are same, it will be C square R square, which is nothing but what? F is equal to 1 by 2 pi RC. Okay, so based on these equations only, they may give you some value, and based on this you can have the some additional examples. Okay, so this is part 1 of the oscillator. So another video I will do part 2 of the oscillator. Please go through this. Thank you.